Good morning or good afternoon to everybody. Thank you to be here and for watching this video. This is a presentation of our research. The title of the research is Lamborghini Urus, a case of digitalized assembly line within the Industry 4.0 framework. And I'm here, my name is Matteo Rinaldini, and I'm presenting together with Sara Caria, my
Hello.
colleague Sara Caria. And we are presenting this research about the interplay of human intervention and digital technologies in lean production. In particular, we present an empirical analysis of how digitalization is introduced into lean system within a firm located the Lamborghini in the Italian Motor Valley, where technological innovation is inspired by the Industry 4.0 approach. Regarding the debate about digital technologies and lean production from the beginning of Industry 4.0, the socioeconomic literature has focused on the issue of the relationship between new digital technologies and lean production system, and over the time, the scholars' interest gradually shifted on the characteristic of this interrelation, this relationship. Summarizing, on one hand, several studies suggest that digital technologies support the development of the lean production because the typical Industry 4.0 digital solution help to overcome lean implementation barriers. On the other hand, we can find an opposite view where the lean system is considered the basis for the implementation of Industry 4.0. At the same time, another significant literature stream has focused on the effect of institutional context on the integration between lean production and new digital technologies, bringing to light the role played by factors inside and outside the firms, including the locally predominant industrial relation system. One important cross-cutting issue is how much room of intervention is left to the human actor in performing tasks when digitalization is implemented in a lean system, and it is strictly linked to workers' discretion and their capabilities. However, numerous several empirical researches show that similar technologies can be implemented in a very different way with variable effects on the machine-labor relationship. And empirical observations suggest that firms approach digital technologies in a pragmatic way. The firms tend to introduce innovation step by step, addressing specific bottlenecks, optimizing existing technologies to improve quality and production over time. In other words, the virtually disruptive transformation scenario based on digital potential seem to diverge from the predominant current use of digital technologies, which suggests that application is adapted and tailored on firms' particular needs, productive context, and external environment. In this line, Mokudai and colleagues in a recent article show that Japanese firms embrace digitalization in support of their lean capabilities, hesitating in the so-called lean augmentation. However, the authors reject the idea of the lean production as a kind of premise for the introduction of Industry 4.0. And indeed, they found that Japanese firm studied by Mokdai and colleagues have selectively and gradually implemented the digitalization. Moreover, the digitalization trajectories followed by the studied firms was inspired by a digital shadow approach rather than a digital twin approach. That means that digitalization of the work process empowered activities related to both data collection and data analysis, but problem-solving activities continue to be to the domain of human actors. In other terms, the new technologies were used for optimizing production through human activities and not for replacing workers' intervention. And the general intent was to preserve the discretionary margin of the workers at the base of the Kaizen system. That is one of the main pillars of the lean system. Um, in spite of that, Mokdai and colleagues uh, conclude that the digital shadow approach does not avoid the risk of impoverishment of the workers' competencies and could lead to a decreased ability to intervene. In addition, they identify a risk of a lean trap, what they call a lean trap, that is the risk of constraining technological innovation in a specific lean organizational paradigm, enhancing the potential of technologies in terms of exploitation, but underusing technologies in terms of exploration. At the end, the authors argue in favor of an important difference between Japanese and German firms embracing the Industry 4.0 paradigm that is considered more oriented to a total self-regulated digital model, opening to the possibility of replacing the human-based Kaizen. On the basis of the paper of Mokdai and colleagues, we present a research aiming at exploring the interplay of human intervention and digital technologies in German firms inspired by Lean principle. We explored the use of digital technologies in the three domains already adopted by Mokdai and colleagues that are operation, Kaizen, and human resource development, as you can see on the slide, in subsequent categorization like production planning control, internal logistics, supply line, maintenance tasks, data collection, analysis, solution generation, implementation, human resource using digital technologies, and human resource for digitalization. We carried out a qualitative single case research design because this methodological option allowed a soft comparison with the inspirational work of Mokudai and colleagues that adopted a similar approach. The case selected is the automobile Lamborghini, and in particular, we decided to focus on the Urus production line, the new technology advanced assembly line corresponding to a new car model launched some years ago. Lamborghini, as you know, is a well-known luxury sport car manufacturer with about 1,800 employees. And since 1998, Lamborghini has been acquired by the German group Audi Volkswagen. Traditionally, the product portfolio of Lamborghini consisted of two sport car models. Some of our field work, these two sport car model were Aventador and Huracan, and these two sport car models target the very high end segment of the market. But since 2018, Lamborghini manufactures a third model, Urus, that is a luxury sport utility vehicle, which is expected to double overall production volumes. Each model has numerous customization options as well as a dedicated assembly line. Uh, the Audi Group takeover marked the transition to a more standardized production and above all, lean system principle in production organization were introduced and reinforced. We are speaking of high performance work practices that were implemented. Hierarchy was generally reconfigured, cycle times were strictly rationalized, and working times have generally intensified. This production reshaping was supported by large investment in new digital and automation technologies. Digital technologies have been introduced in these production lines, but Urus line is the more advanced one, having been conceived as digital since its greenfield creation. It is not a coincidence that Urus production line is the only one where the manufacturing execution system MES is used. And as you know, MES is a dynamic information system that use current and accurate data in order to drive effective execution of every step of the production process and virtually of every manufacturing operation from order release to product delivery into the finished good. Uh, another important factor is that the acquisition by Audi also forget a hybrid Italian-German industrial relations system at company level. Indeed, since the beginning, the German industrial relation, inspired by principle of participation and cooperation between social parties, has interplayed with the Italian system of industrial relation within the context of Bolognese trade union tradition. Bolognese is the area where Lamborghini is located. And this Bolognese trade union tradition is characterized by a strong unionization and bargaining capacity. Over the time, contents and modalities of company level bargaining led to a season of participation which institutionalized the right to information of the parties. So, regarding the field work, most data were collected through some semi-structured interviews with selected employees of Lamborghini carried out in winter spring 2022. Interviews were focused on the use of digital technologies in the three domains above mentioned: operation, Kaizen, and human resource development. And in parallel, we did two visits to the three production line of Lamborghini plant. And obviously, the visit represented an opportunity to collect documents, to direct observe the technology used and its effect on work process. Now I pass the word to my colleague, Sarah Caria.
Thank you. Thank you very much. Okay, going to the findings. Operations are heavily affected by digital technologies, specifically production planning and control. Lamborghini Urus is a highly customized product. That means that customizing options are wide and it is sold on a variety of markets. Each one has differentiated standards in terms of safety standards or requirement as supply traceability and things like that. So the production is quite complex, and MES ensures that the proper standards are respected and it minimizes the risk of errors in the production. Specifically, MES records each progress, each step, calculates the time needed for each vehicle, and learns how to program subsequent steps and reschedule production in case it is needed, in case of a production disruption or some inconvenience occurs. It also can create customized workflows to respect the specific standards or requirements specific to each car according to market demand. As far as processing is concerned, the two types of data are basically gathered, monitored, and processed by the MES. One has to do with the functioning of the machines. That's to say, MES ensures that machines are working normally, properly, that no inconvenience occurs on the machine's functionalities. This type of data is removed from workers' domain. That's to say, it is collected digitally. Although when it comes to generation of solution, when a problem occurs, it still relies greatly on human intervention. A second type of data that MES controls is the task performed. Now, that's to say, MES ensures that every single task planned is performed. And in this case, MES is able to integrate production step more tightly than human intervention. The assembly line, of course, widely used digital technologies. What is really astonishing is that the assembly line is undocked from the floor. It is made of automatic guided vehicles. They're like little cars that autonomously transport the card body from one working station to the next one. And the MES, at the end of the takt time, is responsible for for ordering that each AGV pass to the next station. And it also reschedules time in case of a disruption, but always after a decision of the managers. That's to say, humans decide that times has to be rescheduled, and MES automatically reschedules times. Workers are provided with bracelets that allow a login to the working station. Each worker has a bracelet with his or her personal credentials that enable the working station. One interesting thing to be noticed about this technology is that the system keeps track of time and movements of work, and the system has the potentiality to go much further. It could control execution times, it could control movements, but it is a decision of the management not to use this potentiality of the system. And in this decision, an important role was played by the union, which somehow prevents that digital technologies are used as a form of labor control. So actually, workers are just asked to certify that all tasks have been implemented. So no strict time control is carried out on the implementation. In some workstations, we can find collaborative robots or cobots that can perform activities, especially heavy-duty activities or mentally complex activities, while some other activities continue to be carried out by workers who can activate cobots in case of need. So there is some still discretion margin. A worker can decide if the help of a cobot is needed or not. The internal logistic is also quite digitalized, and it is another part that is astonishing. All supplies are located in what they call supermarket, which is located just beside the production lines. So operators and small AGVs transport all the supplies and specific semi-finished products. Okay? Operators in charge of the logistics are provided with tablets and sensor-equipped gloves, which keep track of what parts are withdrawn, what parts are released, and like how much of every single part is charged to the system now and used for production. All this data on production is collected and processed by the MES, which keeps a real-time inventory of supply parts and orders automatically replacements when they are needed. Okay, maintenance. This is a field where the digital potential is not exploited to its best. It is actually quite limited. Like the potential of the MES would allow to implement predictive maintenance, but this is not being implemented yet. It has been decided not to activate this function, although the maintenance demand in the Urus line is higher than the rest of the production lines in the factory, because somehow the digital equipment is quite fragile. So, for example, the AGV break quite often. So the people in charge of maintenance have to guarantee a permanent presence on the production line, more than they actually can do on other production lines, on other assembly lines in other tasks. Inspection tasks do rely extensively on the use of digital technology. This allows to detect flaws or imperfections more precisely through 3D representations, although, again, workers are responsible for correcting the mistakes that are digitally detected. One very clear example of this dynamic is the assembly department, which in Lamborghini is integrated. It is part of the factory. It is part of the plant. New digital machines are able to identify tiny little flaws on the leather, which would be invisible to a human eye, even a trained human eye, but the intervention of human is still maintained when it comes to implementing the corrective action on the part. Okay, going to Kaizen, which is a pillar of the lean production system, we can briefly say that data collection and analysis is in charge of the MES. The MES can identify the type of errors, the frequency of the problems, and it also can keep track of the delays caused by each mistake typology or each problem typologies. But then correction or problem solving is in charge of operators. Again, it is a human intervention that finds solutions. Like the MES is able to identify where, in what station or in what step of the production, the problems become evident, but cannot say where it is originated. So it is the operators, like humans, that depending on the type of error, can trace it back to the working station where it originated. So once the problem is solved, MES steps in again in the monitoring. Now, so it carries out a monitoring which is 100% of the production at the beginning. Then it goes to 50% and then 30% reduction. In case of another problem, it goes back to 100%. So, as we were saying, solution generation and implementation still relies on workers, which are the one that decide, that find the source and take the corresponding steps to restore the standard or restore the production if it has been interrupted, and decide in what way the problem must be solved. Last point, human resources development. This field embeds a high level of digitalization. As far as human resources using digital technologies are concerned, digitalization is embedded in in many operations. One that is worth mentioning is a project that the factory is implementing to improving the ergonomics of the working stations and prevent possible problems on workers' health. It consists of a project that uses motion capture suite, and wherein those suites, workers are asked to perform their routine operations. And the system, those suites, can detect some askew posture, some error in the way workers move, possible damage to the back because of excessive pressure and things like that. So again, digital technologies allows to detect things that human perception cannot see or cannot feel or cannot find. Another interesting thing is the training system. Every Lamborghini has a system based on a 3 dots scheme. According to the level of experience of each workers, operators are assigned 1 to 3 dot system. If one operator has 1 dot, it means that he can perform a specific task only if accompanied by a senior colleague. If it has 2 dots, it means that that operator can carry out that operations autonomously. And if he has 3 dots, it means that he can train others. These systems allows to switch people among working stations, replace people when they're not at work, and reschedule, reorganize personnel in case of need. And finally, human resources for digitalization. We saw that the digitalization in our case study was carried out with substantial contribution from already existing personnel. It was the people who already worked in the station that co-organized the introduction of digital technologies. Again, in this case, the action of the workers' representatives, due to the importance of the union within the productive context, has been determinant in the way digitalization has been introduced in the assembly line. One final comment on human resources. At first the lean, but the digitalization pushes these issues a lot further, is the impact on competencies and hierarchies. Like the competencies required to work on the assembly line change are different, and hierarchy related to production also change. For example, team leaders are gaining more and more importance, and traditionally assembly line responsible are losing their scope somehow. So this sort of beyond the decision of the company to change the personal structure, the involvement of people and on the production and the competencies required is actually being quietly affected by the introduction of digitalization. Okay, to some comments on our findings. We saw that digitalization in our case study has been introduced in a progressive and incremental way. Each one, on occasions, on each new model release. Like each model release embodies a higher degree of digitalization, but it builds on previous models. The sequential production structure is still predominant. What we saw is a more flexible production line, but we still see a production line organized into subsequent working station, though, as I was saying before, more flexible, to the point that one single car can be taken out from the line in case of specific problems that cannot be solved, and the car can be just taken off the line without interrupting the whole production line. But we didn't see major disruption in the conception of a traditional assembly line. We saw a predominance of a digital shadow paradigm. That's to say, workers still hold a steady control over the assembly line, even though we did see some breakaway leaps forward, as in the case of automatically rescheduled working files and some other things. But these represents really a sort of exploration, but the core of the production is still under control of operators. When we think about possible future pushing further of digital twin dynamics, we must take into account that the type and market positioning of the specific product of our case study. It is a very expensive car which leaves scopes for a wide scope for profit, and it has a really top marketing position. We also have to take into account the very specific industrial relations that are embedded in the production. Unions do play an important role in decision-making process. So they somehow check that no risky decision is made as far as workers' well-being is taken, to say it some way. No? Like they care, and they care that workers maintain an important role and are still central to the production system. A few words to, as far as the lean trap is concerned, we think that as far as we could see, the risk of a lean trap is still present. Somehow our comments is that it is structural, it is embedded in the type of production that we see. Like to escape a lean trap, industrial relation system and productive organization should co-evolve together to a system that overcomes the lean paradigm. And for the moment, we think it is a too complex issue. We didn't really see sign of that process in our case study. Some conclusions referring to the debate we wanted to connect since the beginning. We did find very much many similarities with our inspirational article by Modkay and others. Although one big difference in our case studies is the existence of a MES, which is MES, not MES, which is really one big system that integrates all production steps since the client order all the way through the delivering of the car. And that makes somehow a very big difference. It is a much more integrated production than the one described by our colleagues. But still, we saw the digitalization somehow makes production easier and quality control more efficient. But we really didn't see any self-regulating system or a self-learning step. Those are still weak, and somehow this conclusion seems to challenge the perception of German firms as oriented toward the adoption of I4.0 pattern, which imply a digital twin orientation. We can conclude that this shift towards a digital twin is not clear yet. It will probably end up becoming a reality, but still, we still have to. We think that still several steps has to be taken until we come to that point. Well, those were our conclusions. We encourage more empirical studies which could undoubtedly benefit, from which or a study undoubtedly would benefit. For example, it would be interesting to see what happens when this digitalization is introduced in firms that are inspired by in Industry 4.0 paradigm, but unions do not have the same influence as in our case study. And also, we think that it would be interesting to see how digitalization and ecologic transition combine together, considering that somehow the ecologic transition introduces major changes in the way cars are produced. Like they introduce brand new elements within the production system. This was all. Thank you very much for your attention. We will be glad to answer your questions or to fulfill your curiosity or remarks at the debate session.
Okay, thank you very much, and see you for the discussion.
Yeah,
and
see you for the
any
discussion.
question or suggestion from your part.
Thank you.